Bobby, do you?
Yep, go for it.
Great, thanks.
Away.
Let me know when we're ready to go, John.
Okay, yeah, just give us a minute here.
Okay.
All right, we're ready whenever you are.
Perfect. Can you guys see the presentation on the screen?
Yes.
Perfect. All right. All right, so we'll just kind of briefly go over the schedule. I've got about 2 hours. We're going to try to get through all the material. There's quite a bit of material, so we might skip a few sections if it looks like we're going to go over. But we'll kind of do some brief introductions here. We'll kick off into a primer on travel demand modeling. And then we'll take a break, and then we'll come back and we'll talk about the AMATS model structure itself, as well as the AMATS model use cases. And we're going to try to get you out of here at 11 o'clock. So we'll start with introductions. I'm Bobby Wortman. I'm a consultant at RSG. I've been with RSG approaching 4 years now. Prior to working at RSG, I spent 7 years as the principal transportation planner for a metropolitan planning organization in central Indiana, where we had about 4 different MPOs that were kind of directly abutting each other. And so my goal here is to hopefully give you guys a brief introduction or a crash course in travel demand modeling, and hopefully be able to explain how the AMATS model might be different from the standard travel demand modeling process, as well as talk about how you can use the AMATS model in your planning workflows at AMATS. So why don't we take a few minutes here and briefly introduce ourselves and talk a little bit about your role at AMATS, maybe an interesting fact about yourself. What do you want out of this training? And how do you want to use the travel model in your work at AMATS? So John, because I know you the best, I'll pick on you first and we'll start with you.
Okay, thanks, Bobby. Yeah, so I've been with AMATS, I think, 4 years now, 3, 4, yeah. I've lost track. Anyway, interesting fact, well, I had my birthday yesterday, and that was that.
Happy birthday.
Yeah, thank you, belated birthday. Yeah, got a nice card, and we had Hawaiian donuts. Anyway, what I would like to get out of this training is, again, just even though I'm kind of the TDM or the model person on this end, it's always good to get a refresher, because I dive into the weeds and then I come back out and do some other things. So yeah, and I'd like to see or learn how we can use the model more in-house.
Very cool. I'll have you pass it off.
Okay, Joni.
Thanks, John. Yep. My name is Joni. I am the non-motorized coordinator for AMATS, and did the non-motorized plan that was adopted last year, and currently working on the safety plan. And we'll be working on the recreational trails plan towards the end of this year. And yeah, I think I would just appreciate knowing more about the model. I always hear about the model. I don't really know how it works, or kind of, I have an idea of what it's doing, but I certainly don't know any specifics. So it'd be interesting to learn more about what it does and what the capabilities are and how it can help our other planning projects that we're all working on. So yeah, thanks for the opportunity.
Christine Schutte, I'm a planner and the public involvement coordinator for AMATS. Been here a couple of years now. I'm interested to hear about the model and how it works. Kind of like Joni, I know its basic functionality, but haven't ever been into the weeds about what it's doing or how we could be utilizing it.
I'm Aaron, I'm the coordinator for AMATS. Interesting fact about myself, I'm left-handed. Not a lot of people are, but we have some people who are.
And I had a birthday on Monday, so I
Yeah.
have 2 shared interesting facts.
Wow.
There you go, I love it. Our group is so close. So what do I want to get out of this training? Just learn more about the model. You know, I have a decent understanding of it from my work on the MTP, the 2040 MTP, and a little bit on the 2050. But it's always good to know more because it's so complicated and it's not something I use every day. And how do I want to use the travel model? I kind of, as John said, want to use it more in-house for things. You know, we use it, but it's only for really the MTP. I want to see if we can use it for other things. Additionally, I'm working with the state, FAST, the Fairbanks MPO, and the Matsu Valley MPO on trying to set up maybe a regional kind of model coordination group. And so it's good to get an understanding of this, you know, what is the AMATS model? How is it built? What goes into it? Because then I can pass a lot of this information on to that group as the Matsu Valley starts developing their own model. So, thanks.
Is there anyone we got? Oh, go ahead.
Yep, one more, sorry. Chelsea Wardwaller, I'm also planner at AMATS. I manage the MTP. I've been here since about beginning of September, so for about 6 months. So very new and definitely want to better understand how the model connects with the MTP. And I wrote down sort of a slew of questions that I think John may have passed along to you from your presentation to the TAC in February, Bobby. But I'll hold those, given that you might cover some of them till the end. And yeah, just trying to better understand how it works. And I think particularly interested, given the direction our community is going and focusing much more on active transportation, how the model fits together with that sort of maybe slightly change in focus or adjustment going forward. And an interesting fact about myself is that I just traveled to Finland to learn about winter cycling and winter cycling maintenance.
Very cool. And then it looks like we've got some people on Teams as well online.
Chelsea, did you go to Oulu?
I did, yes.
How was it?
It was amazing. I look forward to sharing your presentation with everybody.
I am thrilled to see it. I'm a little jealous.
Randy, do you want to introduce yourself?
Sure. Yeah, let me turn my camera on as well. Good morning, everyone. My name is Randy Brown. I'm the transit planner with the Public Transportation Department. In a previous life, I've been an operator and a manager, and now I'm in the role as a planner. I guess that could be an interesting fact about myself. I'm currently working on preparing for an upcoming service change, and updating some of our bus stop amenity plans and guidelines, or improvement plans and guidelines, amenity guidelines. I'm curious to learn more about the model. It's fairly new to me. Other than that, thank you.
Thanks. And then Bart?
Hello, my name is Bart Rudolph. I am the Transit Planning Manager and Communications Manager over at Transit. I oversee the scheduling, the rideshare, the planning, and the marketing divisions here. I've worked at DOT and MPOs in my previous life. I'm kind of like Chelsea. My whole career has been the model is everything. And how are we going to build more capacity and more roads? I really want to find out how we're shifting to this non-motorized and how the model will help with that. Also curious on how transit is incorporated into this model and how we model future scenarios with more people using transit, and how easy that is. Because I've also heard that model runs are expensive and we can't do a ton of them. So like, what can we actually do outside of the MTP with the model? So yeah.
I think that's it.
Awesome. Well, great to meet everyone. The The first section here, section 2, actually is going to cover travel models 101. This is going to be about half of our training, and this is really just to get you used to what are travel models, where do travel models fit in your workflow, how do they function. We're going to kind of go into the basics first. So learning about modeling can feel a lot like drinking out of a fire hose. They're complicated. There's complex math involved in them. There's complex data requirements in them. And so it can get overwhelming really, really quick. So as we're kind of working through this training, if you're starting to feel that way, note that I think it's normal. I think when I first started learning about trail demand models, I felt this way. There are times in my career, even still, where travel models can get so complicated, work and feel like that still to this day. So if you're feeling confused, feel free to speak up. I prefer to kind of teach in an informal context. So feel free to raise a hand or interrupt me. I know that's virtual, so it's a little bit of a different kind of learning environment. So we'll start with the 4-step model. And the 4-step model is the most travel demand model, or most common travel demand model structure that you're going to see in your career. And there's more advanced structures, but we're just going to really focus on this 4-step because 1, it's relevant to the AMATS model, and 2, it's likely what you're going to come across in most modeling contexts. So the goal here is to identify our current transportation or identify current transportation planning issues, describe where travel demand model fits in within the transportation planning process, and be able to just name what the 4 steps of the TDM process or travel demand modeling process is. So what are the 4 steps? So there are 4 basic steps: trip generation, trip distribution, mode choice, and trip assignment. I've also included this little hidden step here, and we call this the time of day directional factoring. And that's kind of a hidden step because as models have developed over the last 75 years, the ability to parse out daily information into period information has become more and more important. So this paradigm, this 4-step paradigm, was originally created in the 50s, and it's been improved and expanded upon throughout the years and years and years. So what is trip generation? Trip generation is purely we're forecasting the number and the purpose of the total amount of trip ends that will be made within the region. And in trip distribution, we're determining where those trip ends are going. Mode split, we're predicting how trips will be divided among available modes of travel. And those are modes of travels that we define. So that could be car, it could be transit, it could be carpool, any other kind of slicing of different modes that you'd like to make. And then trip assignment is going to predict the route choice, or really simply the total number of trips that we're going to assign onto individual highway lengths. So that's your highway volumes. If we're putting it onto transit networks or transit routes, we're really predicting the total number of linked transit trips that we're putting on each route. So I think it's important to kind of note that there are transit boardings and there are transit trips, and our boardings are always going to be just the on-off on the bus or the train, and your transit trips are going to be factored in with different with transfers. So in trip forecasting, it's the process of using a calibrated travel model to forecast travel for the future year. So in travel demand modeling, typically we're talking about base year conditions, and when we go into forecasting, we're forecasting those into the future. And the way that we forecast things into the future is we calibrate the base year conditions, and we validate the model is representing the base year conditions. So that could be 2019, for example, for the AMATS model. And once we've kind of replicated or confirmed that we've replicated the base year conditions, we then assume that those conditions are going to be the same in the future. And that kind of forms the basis of how we use or the basis of travel demand modeling. And so it's important to note here, we're gonna kind of dive into a little bit of more detail in each of these. We're not gonna go super deep, so we're not gonna get into the level that you would need to know if you're estimating these things, but we'll go into them in a little bit more detail of just the functionality of them, because I think it'll help demonstrate how the AMATS model is a little bit different. And the big thing here also to note is the significance of these arrows. So in the travel demand modeling process, it's sequential. We run from one step to the other. So first we do trip generation, then we do trip distribution, mode choice, time of day, and then we assign those trips. So the sequence is important in addition to the 4 steps themselves. So what is urban travel demand modeling? Travel demand forecasting is the intersection of network supply and demand, and measures how well supply accommodates demand. So when we talk about network supply, we're talking about transportation options. And those options could be highway options, the total number of lanes, the total number of HOV lanes. It could also be, when we're talking about demand, we're talking about the population and employment characteristics. So it's people at the end of the day who are using the transportation system, and we're forecasting that demand based off of how people are traveling and why they want to travel and where they want to travel. And the travel demand forecasting or travel demand modeling is really just a tool that we use in the urban transportation planning process. It's a big tool, and I think it's important to note that in most MPOs that I've come across, we build the travel demand model up to be the tool that we go to, and it is a really important tool, but it is not a tool that is going to answer every question. So in the planning process, in the context of transportation system performance, we need to also make sure that we're bringing in other tools that are covering the blind spots of what the travel demand model is are forecasting. So the travel demand model is only as sensitive to what we make it sensitive to. And if the travel demand model is not sensitive to a policy or planning question that we're asking, then the travel demand model is not going to be a good tool for that analysis. And modeling can estimate, and based on assumptions about transportation system users in the future, it can measure how changes in size and character of the population will impact the transportation system. As more women have entered the workforce throughout the years, for example, the increase in the number of work trips per household has placed a greater peak hour demand on transit and highway facilities. And we can measure these types of changes in household characteristics and household trip making characteristics through the model. And this is where really the power of the travel demand model comes into play, because it provides us estimates of system usage and performance, such as the number of cars using a future freeway, volume of passengers on maybe an express bus route, or the number of people who may have used a proposed toll facility. There are also different techniques in travel demand modeling that can be used depending on the requirements of the analysis and what questions are to be addressed. So there are different types of tools. Vision eval is one of them, where we have sketch, regional, subarea, and corridor analyses, and strategic planning models that can forecast in different contexts and can help support the travel demand modeling context or process as well. So where in transportation planning does the travel demand modeling process typically fit in? And it's a means to the end of effective planning results. So here we have the transportation planning process, where we go through the process of developing goals, objectives, evaluation criteria, of developing the vision for the region. And then we want to assess current and likely future problems, develop alternative solutions, evaluate those alternatives, and then assist in decision-making for what the regional policy is going to be, or what the statewide policy is going to be. And travel demand forecasting can play a role in the middle of these processes too. So as the MPO or the state is developing their vision goals and objectives and their performance measurement or evaluation criteria, those should be incorporated into the travel demand forecasting process. So you want to make sure that as you're thinking about the travel demand model, what does the travel demand model do? What are the planning questions that you're going to ask? Because there needs to be a feedback mechanism in the design of the travel demand model for the planning process that the agency is following. Otherwise, you run the risk of developing a travel demand model that isn't sensitive to the policy questions that you're asking in the region. So it's really important to have that feedback mechanism in your planning process with the travel demand model. You don't want to develop the travel demand model in a silo as its own thing. You want to make sure that you're developing the travel demand model and your planning processes concurrently with enough feedback so that the money that you're spending on the travel demand model is answering the policy questions that you want to answer. So what issues are we trying to address? The current situation facing transportation plan differs from days when the four-step model paradigm was initially developed. For the most part, the interstate highway system is complete. There might be a few last pieces out there that we're completing, but for the most part, we're done building the interstate system and most of the country's highway systems. So there's a new emphasis on the efficient management and operation of existing facilities with less emphasis or increasingly less emphasis on new construction activities. So back in the 50s and the 70s, we were really pushing for expansions of highways, interstates, and transit expansion projects. And now we're really looking at things like congestion management. What's the impact on air quality? What are the environmental justice or equity concerns? We're looking at pricing policies. So this is if we toll a facility in a region, are we going to be able to help manage the demand in the region through pricing? It's looking at new rail starts and other transit projects. It's looking at changing population household characteristics. I think that if you were to take slices of what the standard American household looked like in the 50s and compare them to now, it is quite different. And so with the changing population household characteristics, we get changing underlying travel behavior characteristics that's changed too. And so you can think of a newly married couple versus a retired couple and what their travel behavior changes are going to be. And those are going to be quite different. And so the model can help kind of answer those questions of what's the impact of changing population and household characteristics. And then we have things like the interaction of land use and transportation. So we can't do transportation planning within an entire vacuum. We have there's an interaction that occurs where the underlying land use really impacts what that transportation is going to look like. And what the travel behavior is going to look like too. So you can think of a compact smart growth development is going to encourage more walkability than a suburban greenfield development of single family houses that'll be by default auto-oriented for the most part. And then what's the impact of commercial vehicles? And I think commercial vehicles has been an area that has been improving in travel demand modeling, but it's an area that there's probably still quite a ways to go or quite a ways left in the process to improve that. So how does the travel model fit in with other tools? So here we kind of just look at the different tools that are related to the travel demand model. We can have multiple different tools that interact with the travel demand model. And it can show, and this kind of shows how the results of the travel demand models feed into other quantitative analysis tools used for transportation planning. And that can include traffic microsimulation. It can be user benefit analysis for benefit cost analysis. It can be revenue forecasting models, air quality models. And there's lots of other tools here too. So this Vision Eval would be another tool that we would include in here for strategic planning. And these can all interact with each other. So for example, a land use model can have a direct interaction where the land use model is predicting where people are going to locate, where businesses are going to locate. And a big factor of where businesses and people locate is the accessibility, the transportation accessibility to employment, to shopping, access to out of region travel. So that'd be the interstate system. It would be ports and things like that. And so you can actually create interactive or interconnected land use and travel demand models where they feed off of each other. So the land use model runs, right, that directly inputs into the travel demand model, into the land use inputs, and then the travel demand model runs and generates new accessibilities, which are fed back into the land use model. So you can actually create an interactive land use travel demand model that takes those into account. And there's multiple different versions of land use models, from very simple equilibrium-based travel demand models. Those are models that will reach a set convergence criteria. That is, that they reach an optimization or maximization point and stop running and converge, as we would say. Two, we have microsimulation tools. Those the most advanced would be called PICOS. That's what was developed and largely implemented in California. And then there's other microsimulation land use models too, like UrbanSim. And then the travel demand model can run, and we can output the results of the travel demand model to work into these other various different tools. So an example would be if you were doing a corridor analysis and you wanted to start looking at signal optimization within the corridor and an individual intersection ability, you'd want to take the sub area, the corridor, from the travel demand model so you get the right overall amount of trips. But then you want to micro simulate that traffic so you can get operational level details at the intersection level. So the travel demand model isn't necessarily a good tool for looking at individual specific intersections, but it's a good tool to feed into the type of analysis that you might want to do for intersection design. So next, we're going to talk about surveys and traffic counts and what role do these play in modeling. So travel surveys are the backbone of travel demand models and provide basic behavioral information that is used at each step of the travel demand model. And so travel surveys are therefore a vital part of the travel forecasting process. And here we can, in orange, I talk about, or I show travel surveys and just how these feed into each of the processes. So for example, the travel survey lets us create trip rates that then feed into trip generation. The travel surveys give us calibration targets on how far people are traveling in a household and where they are traveling to. And then travel surveys also give us parameters and calibration targets for mode choice too. So they tell us, what does the share of travel need to look like in the region? That allows us to calibrate the model or directly estimate if the data is good enough, how people are choosing their mode of travel. And then the other big source of data in travel demand models is traffic counts. So at the end of the day, for trip assignment, we need to have two things to calibrate. We need some sort of observed set of data on the roads and then on the transit system. So we use traffic counts for highway assignment, and for transit, we typically use boardings, and that the boardings can be based off of data that's collected by the transit operator. And in some cases, we actually can get linked transit trips from the transit operators too, where if you had to use like a fare card, your linked fare card could be traced through the entire system for the type of transfers you're doing. So some key concepts here: the importance of data. A comprehensive and ongoing data collection program is essential to support the travel demand forecasting process. Our models describe travel behavior. Data is essential to understand this behavior, such as the number and types of trips, their origins and destinations, and mode shares. And data collection should focus on the important travel markets in the region. So when we're talking about important travel markets, we're talking about transit riders. We can be talking about different income groupings as important travel markets too. We can start to define different equity issues, right? Equity groups as important markets to analyze in the travel forecasting process. And I think the equity question is something that's becoming bigger and bigger at MPOs, and it's something that in travel demand modeling we need to start considering is how can we make our travel demand models more sensitive to equity concerns? Because the equity question is becoming a bigger and bigger component of the federal transportation planning process. And then it's important to note here just some of the difference between local data versus transfer data. So in some cases, this isn't really an issue here with AMATS because you guys have collected your own travel surveys. But in some areas of the country, it's common. There's not necessarily the funding that exists to support a household travel survey. So it's really common for model developers or regions to find a similar market or similar region and transfer and use that survey data to estimate models in their region. So household travel survey or travel survey types, there's actually several different types of household travel surveys out there. I think the two most familiar, and I highlighted them in bold here, are traditional household travel behavior surveys and transit onboard surveys. Those are really the backbone, the ones that we see executed consistently in regions, and it's also what AMATS is familiar with, but there are also other types of surveys that exist. There are workplace and establishment surveys, there are external station surveys, but this is largely being replaced by the use of passive data. So we used to do all sorts of different external station surveys using intercept cards, using Bluetooth, but now with the advent of passive data, using your cell phone or connected vehicle data, it's a lot cheaper to get information on external station and external surveys into your study area from that. And then we have truck surveys. I highlighted here in bold non-resident or visitor surveys because this is typically something that the AMATS region has not done. And it's really common in areas that have huge travel or huge visitor populations to have a completely separate visitor model that is embedded within the travel demand model that is estimated based off of a non-resident or visitor survey into the region. So that could be something that AMATS might want to look at in the future. And we have things like stated preference surveys, panel surveys, and longitudinal surveys. And stated preference surveys are typically conducted if you're testing new transit options. So I can think of an example from my last MPO where we were really interested in looking at what's the feasibility of commuter rail into the Indianapolis metropolitan area from the suburbs. And so what we did was we used the household travel survey to identify people who are taking trips into the downtown Indianapolis area from within our metropolitan area. And then we would subsample them and give them some basic information about, if you could pretend that there was a commuter rail system here and it operated under these set of conditions with this rate, would you choose transit or would you not choose transit in those situations? From there, you can actually develop different models and analysis in the discrete choice framework that would allow you to develop ridership estimations of ridership for a proposed but non-existent system. So that can help you kind of track the trajectory of different proposals with stated preference surveys. And then there are different data inventories that become really important for travel demand model. All the data listed in this table, with the possible exception of transit inventories for very, very small regions, are required for the development or the application of a travel demand model. The level of detail of each data type varies from region to region and according to its needs and the level of available funding. And there's other data needs that we can discuss later. But we, for the most part, will focus on server data and traffic count data in this part. So mapping data sources, where can you find these? State DOTs, US Census Bureau. There's commercial digital map files that are out there as well. That would be like Cure data, where they actually just go out and collect all the information on the roadway already. And then they provide that in a JS context so that you can just import that into whatever you're using. There are scaled maps, which are almost really rarely do you come across scaled maps. Those are basically digitized maps, paper maps that were scaled to work in modern GIS software. There's OpenStreetMap, and OpenStreetMap now has data on not only the roads, but there's Open Bike Map and there's Open Pedestrian Maps now too. So it provides a lot of different information that is crowdsourced. And then there's new passive data as well. So we have location-based sampling, or LBS data. That is a lot of the cell phone GPS or cell phone data provided for big data has typically in the last 5 years come from smartphone applications. So if you enable a location-based service on your phone for whatever app is on your phone, that data is likely being sold. And then it's sold to data aggregators, and then it comes out in passive data that can be purchased for origin destination analysis. There's GPS data. That GPS data is going to be primarily from things like ATRI, where they're providing truck GPS data. And then a new vehicle or new data source that's come out now is connected vehicle data. So if you drive a car that has a integrated maps into it and connected to a vehicle call center, that data is now available and has become available in the last 2 years. And that connected vehicle data has things like origin destination data in it too. It also has a really powerful set of vehicle event data around crashes too. So the connected vehicle data can be a really powerful data source for safety analysis, just because it has all the vehicle crash event data in it. And that also includes like what the driver was doing in the moments before a crash. So you actually can tie that to some of the behavioral information. And kind of what we don't know about connected vehicle data is the underlying equity issues. So is it primarily, what is the bias in there? And I think there's a suspicion that the bias is that it's people who can afford newer cars, that cars are produced in the last 10 years. And so there's probably some important equity considerations if you're using connected vehicle data to help adjust for or account for that bias data set. And of course, there's other data sources, state DNR, USGS. I think the best source of USGS data is that there's Landsat data that provides essentially raster data that can be used to look at like urbanization impacts. So you can use that data to kind of see what the rate of urbanization has been like in your community based off of infrared satellite imagery passes over several years. And that can be a very powerful data set for modeling, especially if you're looking at capacity constraints in zone, of how much of that zone is truly built out. So next we'll talk about land use data and networks and its context in transportation land use forecasting. So we have zones and networks. So this is an example of a travel analysis zone. So was there a question or was that a cough? I think it was a cough.
That's tough.
It's called.
So the underlying geographies that we use in travel demand models are links, networks, nodes, and zones. So links are roadway or rail segments. The link attributes typically include things like the beginning and ending node, nodes, the length, the capacity, the speed, area types, etc. And you can kind of see here on this map. So what we're showing here is essentially a 4-zone or 5-zone system, right? And can you guys see my cursor? Yeah. Okay.
Yeah.
All right. So the zones are outlined here, or the links form the boundary of these roads. And our networks are the electronic representation of the existing transportation system. So all of these connected lines here, for example, are basically the transportation system or the roads, and they mathematically are represented in the model. And they can include both highway and transit systems. And the network is comprised of a combination of links and their nodes, or their stopping and the endpoints. So the nodes are the endpoints of the links, generally located at roadway intersections. Nodes can be located along roadway segments to more accurately represent roadway alignment. And the combination of the nodes and the links is what our transportation network is. And now today, if you were to look at a model system from the 50s, you would see a big stick network. Today, now our transportation networks are built on top of GIS systems, and they get to close to military levels of precision on road centerline data. So we basically know that the networks are, precision, usually within a few feet of where the actual center line of that road exists. And then the basis of the geography that our transportation network is tied to are zones or travel analysis zones. And these are just small geographies, and they're generally referred to as travel analysis zones. They're also referred to traffic analysis zones. I've also seen them referred to as transportation analysis zones. They all essentially are the exact same thing. And the TAS size and boundaries depends on the model application, the functionality of the road network, the underlying census data of the zones, and then natural and man-made barriers. So in general, when we delineate or draw travel analysis zones, we want to make sure that we're drawing the zone so that it's bordered by major roads. So in general, on a travel demand model, we only model collector level facilities and higher. And we make sure that those roads form the boundaries of travel demand models, or sorry, the boundaries of the transportation network form the boundaries of the zones. And then we also take into consideration general natural and man-made barriers. So you can think of the other side of the railroad tracks type of issues that happens with self-segregation in communities. These natural barriers are important to make sure that we're representing in the travel demand model context. So we want to make sure that if there is a rail line running through, that we divide on the rail line that has important travel behavior considerations so that we don't wash away differences that man-made or natural barrier causes, but also has screen line implications too. So when we're measuring hard barriers, those are areas that the cars can only have a set amount of crossings. Those end up being really powerful validation criteria in the travel demand model, and we want to make sure that they're represented accurately. So land use estimates are directly used in trip generation and mode choice steps of the travel demand modeling process, and they indirectly influence trip distribution and trip assignment. Note that ultimately transportation through accessibility will influence development patterns, resulting in a change in land use. And as you'll see, there's a land use and transportation relationship that works together and changes over time. So can anyone think of any examples of how land use might affect mode choice?
If you have a trail in your backyard, you're more likely to bike or walk on that trail.
Yep.
I mean, if you have like destinations closer to your house, you're more than likely, take transit or bike or walk. So for example, if a shopping center or like a grocery store is, 10 minutes away, you may bike and walk instead of taking the car, versus if it's 4 miles away, you're guaranteed to only take one or two choices. So it gives you more opportunities to choose how you commute or how you get to that destination.
Yep. Any others? All right. So in a travel demand modeling context, what is land use? And in TDM terms, land use typically refers to the number, type, and location of households, the number, type, and location of employment, and some additional socioeconomic data. And land use means many things to many different people. Some of those meanings can include zonal demographics, regional forecasts, the relationships of site design and travel behavior, relationships of regional characteristics such as job housing balance and population density, smart growth concepts, and sustainable development or livability or resilience concepts too. And there are different ways to sensitize the model to these things too, and we'll talk about that later of work that we did to help increase those sensitivities in this update. So why do we care about this? Land use generates the demand for transportation facilities, and these estimates are a major input into the travel demand forecasting process. The type and location of population, households, and employment set the stage for travel activity estimation, or in other words, these estimates are essential in estimating where people live, work, shop, recreate. And the big thing to understand is that bad estimates cannot be corrected later in the travel demand forecasting process. Once the land use estimates are input into the travel demand process, the number and location of trips, mode of travel, and route choice will be determined. And you can't correct for unreasonable land use estimates in the subsequent steps of the travel demand model process. The trips will just simply be at the wrong place and the wrong rate or frequency. So the big underlying thing here is that if you take garbage data and you put it into the travel demand model, you're going to get garbage data out of the travel demand model. So it's really important that the land use information that we're putting into the model is really reasonable, has been verified, and that the forecast information that you're putting in the travel demand model is also reasonable. The underlying land use data in either the base year or the forecast year is the number one most, one of the largest sources of forecasting error in travel demand models. So we want to make sure in the base year that we're getting that right, but we also want to make sure that when we're forecasting the land use information, and oftentimes we get forecasts in larger areas than the travel demand model, for example, or sorry, than a travel analysis zone. And so the forecast might be at the regional level and has to be allocated into the zones, or the forecast might be at some sort of district level aggregation of zones, or it could be done at like the tract level. And then we have to, at some point, sub-allocate into the travel analysis zones. And that sub-allocation process is where we can get lots of forecasting errors, because one of the common things that can happen in travel demand modeling and when we're forecasting is we don't take into account the land carrying capacity of a travel analysis zone. So oftentimes when we're growing, what the forecast is going to be, and then we're allocating to the zones, we're not looking at, well, is there room for that zone to grow? Is half the zone that we think that that can be grown into? Is that actually developable area? Have we looked at that? Have we looked at the underlying, is it in a wetland? So it's often for us to say, hey, there's capacity in the zone. We can see that maybe only 50% of the zone is at capacity, and then we allocate into that zone, but then we later find out that half of that zone is protected wetland. And no, you can't put any more population in that zone without changing the underlying land use planning activities. So we want to also make sure that we're overlaying, like, what is this area zoned for, and what is the reasonable way that this area can grow? And that is going to determine what kind of land use forecast you get. And then from there, you can develop your scenarios that might be based on more compact development, infill development, and things like that. So like my last MPO that we worked at, we were really focused on infill development. And so one of our scenarios at the last MTP was looking at, okay, what are the areas that we can infill? So if we take all of our growth, like, can we just put that into infill development? And how does that change the travel pattern versus if we do like the status quo where we're just building, cookie cutter, like a stamped subdivision, new subdivision, new subdivision, new subdivision. And so these land use policies and projects are increasingly tied to transportation solutions. And I think that You're probably all aware of that just in your work here, that the underlying land use and the transportation system is all intersected together. So typically we get a few different common data formats. We have this is an example of just like what it might look like in a model. We have, zones and rows here. And then we just have like the total population, the households, what the median income is, and some employment typically broken out in like basic employment. So basic employment essentially is manufacturing or basic sector employers. Those are employers that create other jobs, other retail and service employment. So as basic sector jobs increase, non-basic jobs in retail and service increase. As basic sector employment decreases, that'll also result in a decrease of retail and service employment. And that concept of basic and non-basic employment is really standard or really incorporated in travel demand modeling in the forecasting process. So this kind of just shows what a common data format might look like in travel demand modeling at the zonal level of the data that we code into it. And where does this fit in? Again, land use estimates are input into the first 3 steps of the travel demand model. The trip generation step, we're forecasting number of trip ends, produced or attracted in each zone, and that may be based on households by household size, by income, automobile availability, employment by type of employment, that's basic, service, retail, and number of households, and household age, the household age profile. And then trip distribution determines where the produced trips will be attracted and may be based on spatial distribution of households and employment. And typically household and employment forecasts affect trip distribution indirectly through trip generation. So trip generation, we are creating the trip ends that are being produced and attracted to, and that loosely relates to or will relate to the underlying trip distribution. So if you have a lot of production attractions in one area of your region, that's naturally going to draw more trips into it when they're distributed. And then mode choice determines the mode of travel primarily based on time and cost differences between highway and transit usage, characteristics of the trip maker and the characteristics of the trip. And the characteristics of the trip maker are based on the trip maker's household size, their household income, and automobile availability, and that's how they're kind of incorporated. And that can also be included in things like parking costs as a zonal attribute. So if you can think of like downtown areas where parking fees might be high, and I think this really varies regionally. Because like in Indianapolis metropolitan area, there's only one area where you have to pay for parking, and that's in downtown Indianapolis, and then everywhere else it's free. So parking costs may or may not be a huge factor or not, but it becomes big factors in large metropolitan regions like New York or Boston or something like that, where the parking cost might be a significant detractor for someone to drive alone or drive their car in or take a transit usage or transit trip. And of course, the sources for this data are the U.S. Census. There's also the Census Transportation Planning Package. And that's really kind of pivoting now towards the American Community Survey. I think, 10 years ago, CTPP was really big, and then AASHTO and the census have been kind of reducing the importance of that data. State Employment Commission or Departments of Revenue, their market research listings, local area population employment data. We can use aerial and satellite remote sensing capabilities, state departments of financing, and various local planning departments to get us information. And data must be formatted specifically for use in travel demand forecasting models and should be distributed into the TASs. And here you can see we take our base year households and our base year employment data. We allocate it in the travel analysis zones. Then we use various different household classification models to take that information and produce the different markets that we need to be used in the travel demand forecasting models. So we'll talk about that too, because later on in AMATS, because AMATS has a fairly sophisticated household classification model for how it determines the various different markets in the travel demand model. And then future year estimates, it's usually wise to start with a land use forecast to assume a control total for the region or subregion. So at the regional level, or if we're doing a statewide model at the statewide level, what is the regional control total for all of our housing, demographic, population information? And when we sum up, right, so when we down allocate, that should sum up to the control total. And if we don't sum up to the control total, then what we want to do is make adjustments so that we're matching at the regional level the right overall mix and amounts of housing characteristics, person characteristics, employment characteristics. And these forecasts are usually developed by the state economic development agency or employment agency. In many states, they will purchase different economic forecasting models. So REMI is a very common one that's used by many states. And then there are typically regional forecasts that can be used, and then they're often suballocated to travel analysis zones involving various degrees of complicated or simple steps. And there's some issues with this too. There can be complicated technical steps in forecasts. There can also be complicated political involvement in forecasts. So in my region, we had parts of our region that were growing at very rapid paces. We're talking 10 to 15% growth rates. And so the landscape was changing really rapidly, but there were other areas that were stagnant and there were other areas that are declining in population. And so we often would run up against political issues where a economic development agency or a mayor's office didn't really want to show that their region was declining in growth. And so you can get into complicated political steps with these processes. And there's even steps too where there are other cases too where agencies develop really sophisticated land use forecasting models, and then the objective land use forecasts don't necessarily produce location or results that political leadership agrees with. And so that can become a very complicated step in the whole forecasting process. And so in this land use transportation forecasting review of what's important, the sources of population, household employment data. So we have State Department of Revenue data, federal data sources such as the Bureau of Economic Analysis, US Census data, private data sources. That could be from Dun & Bradstreet. It can be from Data Axle, which is formerly Info USA or Info Group. Factors influencing household employment location can be things like transportation access to labor, customers, suppliers, and shipping, local zoning regulations. It can be quality of the school districts. Advantages and disadvantages of qualitative methods of land use forecasting are political alignment, local knowledge, and advantages and disadvantages of quantitative methods of land use forecasting are their objective, and they can be sensitive to known research and understanding, but that doesn't always line up with local conditions. So we are at 10 o'clock Alaska time, and I think I owe you guys a break, so I want to give you that break because it's been an hour. And then we're going to dive into some of the 4 steps and get into the AMATS model information. Are there any questions before we take a break?
Doesn't look like it here. Bart or Randy, do you have questions?
No, nothing from me.
No, thank you for asking,
All right.
John.
Okay, so
Won't we regroup at 10:10?
Sounds good.
Okay, thanks, Bobby.
All right. Looks like everybody is back, I think. We'll move on. All right, so the next few slides, we're going to try to quickly go through the basic 4 steps. I'm calling it a crash course in 4 steps. A lot of this is adapted from coursework that I've taught at university. Some various other trainings that were significantly longer, so we're trying to touch on the surface of things, but not get into the weeds too much. So trip generation is the first step in our 4-step model. All trip generation models use those land use estimates combined with trip generation rates from the household travel survey to produce trips by zones. And then the trip generation model is going to produce productions and attractions by trip purpose. And then those will feed into the subsequent steps in the modeling process. So the key messages for trip generation models are that they estimate trip ends for every travel analysis zone based off of zonal characteristics such as household and employment data, and trip rates estimated from observed data or the survey data. And it's important to note that markets are an important element here along with the trip type. So we often stratify trip generation by things like the trip purpose, the household market, the area type, and other important characteristics that we want to carry through the modeling process. So what type of variables or market types do you think are important for estimating trip generation in the AMATS area?
Shopping centers, I think, would be one. Wouldn't it?
So we're not at the land use. Right now we're at the stratification of households or people. So it might be so this might be the purpose, right? So if you're making a shopping trip as opposed to the destination, yeah. Yep.
Shopping trip, work trip.
Yep.
I mean, recreation trip.
Yep.
These are the different markets they're asking us.
Yeah, and so we're kind of, we talk about stratification of trip generation and markets, so just household market stuff, so that could be the purposes. It could be things like the people's income ranges. So the trip generation, like I said, is the first step. Oh, what was that?
Household makeup, is that part of that? Like who lives in the house? How many people live in the house? What age they're?
You could stratify by age ranges. It's not typically done. So we would think about an aggregation of markets. So you could stratify by age range. That would be one way to do it. Typically, I think income is the most common. And so one of the ways that you could test this, right, you could estimate different models based off of different market segmentation criteria. And you could do it by age, you could do by income. And you could test to see how well those market segmentations actually produce, estimate and replicate the observed travel characteristics. So sometimes we think about what are different markets that we want to be able to parse out of the data. And so income is a big one because income will eventually get routed through the entire model system through each of those steps. And we'll actually assign based off like income categories. And then from there, when we're looking at like project level impact, say that you're doing a widening project, for example, you can start to look at like who is being impacted by that project and who is the biggest beneficiary of that project. So in a larger metropolitan area, right, you might have an interstate project that's done in the central city. So imagine a multi-county region, and you have a big interstate project or interchange project that's being done, and that might be being done in one of your environmental justice areas, right? And so you might say, okay, we have this transportation project, we're investing $45 million. It's in an environmental justice zone, but then when you look at like who's benefiting from that project, who's actually using that interchange, that it might actually be carried through to the people that you're identifying in your environmental justice zone. So if you're looking at environmental justice, maybe through the lens of income, right, and low income individuals who make less than $25,000, well, if they make up a fraction of that $45 million, maybe 1% of their trips are routing through the interchange, then that's not really a project that's benefiting that environmental justice zone. So we can kind of think of some of the things that we want to carry through the entire model process and how it relates back to the environmental justice that we might be doing as planners later on, to look at project benefits and user benefits and who's really benefiting from these projects.
I just have a question regarding that point, because it's it can be a little misleading, I think, to think that interstate improvement or interchange improvement through an environmental justice area might be benefiting that group. But I mean, essentially, anytime you're going to pave, or perhaps it's an existing project, but if it was a new project, if you were looking at putting a interchange or interstate through any kind of area, that's not going to benefit the folks that are living there at all. So it's, if anything, it's gonna be a health concern and, disrupt their neighborhood and their ability to live and walk and whatever. So I'm just wondering, like, how does the model, incorporate that, trip generation, I guess, into, or with abilities to like walk and bike or access areas without having to get in a vehicle. Does the model do that at all?
Yeah.
Or how are you guys looking at that?
So I think it's important to kind of touch. So one, in the example that I gave you with the interstate, we're talking about later on in the steps of how we would be able to identify or measure impacts. And that could be an interchange project on an interstate. It could be a roundabout project in a local community. And so if you wanted to look at like the travel benefits, right, of who's using the roundabout, right, you could actually later on measure that based off of the amount of auto trips and their market segmentation. If you were looking at under 25,000, you could actually pull out of the data, right, the amount of trips that are being estimated to route through the roundabout. And you can look at who's benefiting from the roundabout, the primary benefits of the roundabout from a traffic perspective, right? And there's other benefits of roundabouts too, right? We have safety benefits. You have environmental benefits through reduction in congestion, which is going to improve air quality and things like that. So the model's not going to answer all of those questions, but it can help inform of who's benefiting from a project based off the amount of trips that are going through it. And that kind of starts at trip generation, where you're looking at market segmentation of those. So if you just have trips that are segmented, that are just segmented by, say, purpose, you're looking at your work trips, your recreational trips, your shopping trips. If you're just stratifying it at that level, right, you won't be able to pull out any of the income-based stratifications later on unless you start looking at income-based stratifications in trip generation, right? So you have your purposes, right, and then you can stratify based off income categories, and then you generate the total number of trips. And at this point in the process, right, we're not looking at the purpose of those trips yet in terms of the mode share. We're only looking at, is this a work trip? Is it a shopping trip? Is it a recreational trip? We're not looking at the mode that person chose to get to that area. We're just looking at, did they take a trip? And is that trip one of these purposes? And then is it also one of these income stratifications? For example, if we're doing income stratifications in the generation.
Okay, how are you able to generate, so you're logging the trips and what the trip was for, but you're not able to or identify the mode yet. So how is that, like, how do you log a trip taken by a bicycle or someone walking and using transit versus a a trip in a car, because when I think about trip generation, essentially, and historically with models, I feel like we're always talking about vehicle trips for the most part, but maybe that's totally wrong now. Maybe you guys are, or maybe the model has progressed to a point. I know in the past, it's been really hard to quantify bicycle and pedestrian trips. Like a lot of the
Yeah.
model has been just mostly talking about vehicle trips, and so I'm just, and maybe it's too soon and you're gonna talk about later or whatever, but probably.
We
But
will-
that would be one thing that I think we'd be really interested in, is how do we better quantify, who's walking and biking and taking transit versus are we just modeling for vehicles?
Yeah, so, and we'll talk about some different use cases of the model and how we can sensitize the model to different things, but it's important to note that in the 4-step context, right, what we're doing is we're estimating the trips that people are taking without any regard to the location of those trips, right? Or without any regard, so we're not looking at where those trips are going to yet, right? We're just looking at how many trips are produced in a given zone and how many trips are attracted to that given zone. And by the total number of by the stratified by the purposes or any market segmentation we did. So say we have 4 income ranges, right? Low, medium, high, high, and then we have 3 purposes: home-based work, home-based other, home-based shopping, right? We're developing trip productions in a zone and trip attractions in a zone for the total zone at the household level. And those rates are developed at the household level from the household travel survey. So we know that there are so many home-based work trips by an income category that are conducted by a household, and those are fed into the model. So we're not looking at when someone chooses which mode to take. And there's debate on where mode choice should actually fall, right? In the steps within the industry. And there's examples of mode choice models that you choose your mode before you choose your destination, right? That's one logical consideration that's accounted for in other models. For example, my MPO, we always modeled mode choice before we did trip distribution. So in our area, we thought that the people were choosing their mode first. They're choosing how they're going to get to somewhere. And then once they've decided what mode they've chosen, right, then they decide where they can travel to based off the mode that they've chosen. So there are differences in the whole in the paradigm of modeling in the whole in the industry about where this step might or should occur when you get to when does a person choose how they're going to get to somewhere. But at trip generation, purely at trip generation, we're only really looking at how many trips are produced and attracted in a given zone. So we're not at that point where we're talking about how they got somewhere.
And that's basically based on income level and destination choices, or whether they're going to work or groceries.
Yeah, trip generation is going to be based off of the purpose. And so in the AMATS model, for example, it's based off purpose and the income categorization. And so there are different trip generation rates that for each of those. So there's a home-based work for low income, there's a home-based work for medium low, and so on and so forth for every single purpose that's developed in the model. And that creates the rates for the total number of trips, right, that are being taken. And so, for example,
hey, Robert, could I?
Yeah, go ahead.
I know this. I know that this is kind of a sidebar to trip generation, but that idea of when you assign the mode is really interesting to me. And are we going to come back to that later?
And talking about where we should allocate, we're not necessarily going to talk about the different approaches to pre-destination choice mode choice or post-destination mode choice. I'm happy to stay after and talk about when that might be appropriate or if it's appropriate and where it kind of falls in the process.
Yeah, that's a really interesting concept, and I don't think it's one that I personally have given much thought to, because I'm just like, okay, here's the way we're doing it. But I would like to hear more about the benefit, the pros and cons, basically, of of each type of methodology and why it would be appropriate in one case and not in another. I think that's really fascinating stuff.
Sure. Yeah, I'm happy to talk with you after on those kind of concepts. I don't know if there's a lot of times it kind of comes down to like theoretical consistency, so that can like you can get into the weeds pretty easily on that. But let's get back to chip generation real quick. So we have each trip has two ends, a production end and an attraction end for home-based trips. Trip productions are trips counted at the home end. Trip attractions are trips counted at the non-home end. And for non-home based trips, the origin is the production end and the destination is the attraction end. So this schematic kind of shows a sequence of trips that are made from home to work to shop and back to home. And these actually kind of form a tour, right? So there are other tour-based models, for example, or completely tour-based models or activity-based models where we model the entire tour. These are all linked together. In a trip-based context, these trips are not linked together explicitly. And that's kind of an important concept to understand. The difference between like an activity-based model and a trip-based model is that in a trip-based model, our trips are not linked together. And so we estimate each of these trips independently of each other without regard to them being linked within a tour. So trip productions and trip attractions are computed independently of one another and must be reconciled. So when the independence of productions and attractions in the model is important to note since it means they are not typically equal. So typically there's a process to reconcile them to one another so that you have or balance them so that productions and attractions equal to each other. So when you produce a trips and a travel demand model and you have two different types of trip generation model, you have a trip production model, you have a trip attraction model. And at the end of those, you'll get a situation where the trip productions does not add up to the total number of trip attractions in the region. And you have to balance those productions and attractions so that at the end of them, you get the total number of productions is equal to the total number of attractions by purpose, by market segmentation, and travel analysis zone. And this, again, is a simplistic version of the travel demand model context. There are various different types of trip generation models. There are disaggregate trip generation models. This is an example of an aggregate trip generation model. And see in here, you can see where we take trip generation rates and zone data, it goes into the trip generation model, and then we're essentially producing productions and attractions or trip productions and attractions by purpose. And so we can stratify these by more than just purposes. We've talked about income, and it really depends on what those stratifications should be based off regional travel characteristics and data availability. And we can also divide the travel analysis zone into various levels of residential densities or area types, and things like CBD, CBD fringe, urban residential, suburban and rural, and we can get different home trip generation rates that vary based off of your area type or where you live. So the next part we're going to get to is trip distribution. And in trip distribution, we're taking those balanced productions and attractions that we generated for trip generation. We're generating friction factors and travel skims. So essentially what these friction factors and travel skims are they are cost dependencies, so our cost impedances. So in trip distribution, this takes your productions and attractions by purpose from trip generation and produces trip tables by purpose for mode choice. And friction factors are estimated from survey data and travel skimming data that is essentially zone to zone travel times. And those are factored as a level of impedance in the trip distribution model. So in trip distribution, the trip distribution point of the travel demand forecasting process is where a planner is going to determine where trips will go. So previously we talked about trip generation steps provide the frequency of travel, or how much travel is going to take place, or how many trips will be produced and attracted to or from a zone. And here we're focusing on distributing those trips produced in one zone to all the other travel analysis zones based off the zone attractiveness. And the way that we calculate what the zone's attractiveness is based off the skimming or the path skimming or the cost impedances. So in this case, cost impedancy is just the distance you are away from something. So the basics of a trip distribution model work essentially by saying that if you are really close to something, you're more likely to travel to it. And if you are really far away from something, then you are least likely to travel to it. And that's the simplistic determination of trip distribution. So here you can see how we have our trip generation model, or we have our trip productions that are produced, our trip attraction zones. So this is a simple 2-zone model. And then we have path skimming. So here we have the total number of trips produced in zone 1, total number of trips produced in zone 2, and the total number of trips that are attracted in zone 1 and attracted in zone 2. And then we have this path skimming, and this is the travel time from zone 1 to zone 1. That's the intrazonal travel time, or the reflection of the intrazonal travel time, and from zone 1 to zone 2. So when you're looking at origin destination matrices, or production and attraction matrices, typically the column on the left is going to be the from zone, or the rows are going to be the from zone, and the columns are going to be the to zone. So we take both the information from the trip generation model along with this path skimming, our cost impedances, or the travel time between zone to zone pairs. We put it into the travel demand model, and that's going to give us the attraction of trips, right, from each zone to each zone. So from within the zone and to each zone. And then you can see that these all add up to each other, so they're concurrent, or they're balanced. Next, we're going to get into mode choice, and mode choice is the third step of the 4-step modeling process. It takes inputs from trip distribution, trip tables by purpose, and produces trip tables by purpose and mode. And other inputs usually include things like mode choice model parameters, travel time, and cost skims and zonal data such as parking costs and terminal times. So we have our mode choice model parameters. Those are the influencing factors of why you choose to take a mode. You have things like travel time skims. This is the zone to zone time for each of the purposes, or each of the modes that you're traveling. So if you have a transit in your mode choice model, you need a transit time. So, and you're going to get different breakouts there by in-vehicle time, out-of-vehicle time, and things like that. And then your zonal data. So this is going to be the household, the person level characteristics that go into choosing a mode. So in mode choice, we're taking the mode characteristics, right, for the given mode. We're taking the traveler characteristics, and we're taking the trip characteristics. And then we're going to plug that into a mode choice model. And that mode choice model is then going to give us the shares of things like drive alone, the shared ride, walk and bike, bus, and rail. And it's important here to note too that in the last probably the 10 years, it was very common for a walk and bike to be grouped in travel demand models together. And now state of the practice is to make sure that walk and bike are separate in the mode choice model. So this is a generalized mode choice structure. And it's worth noting here that this really only includes passenger modes when we're talking about the mode choice model. So we're not talking about commercial vehicle trips at all. It's just passenger vehicles or passenger type trips or person level trips. So what are things that mode choice is affected by? It's affected by things like travel time and the in-vehicle time, the wait time, the access to different resources, employment. It's impacted by cost things, and that's going to be parking. It's going to be tolls, fare, auto operating costs. Your other model characteristics, such as reliability of the transportation system. It can be the safety along the transportation system, the comfort. And we have person household characteristics that are going to determine these things like income, autos owned in the household, age. And so this is really, if you have more autos in a household, you're more likely to take an auto trip. On the other modal characteristics, If the route doesn't feel safe and comfort, you're probably less likely to choose to walk or bike. And then we have trip purpose characteristics. This is gonna be things like shopping, the number of shops. And so in general, things that are like grocery store shops are more likely, if you have the availability to take that trip by an automobile to the grocery store, you're more likely to take that trip by an automobile than you are to walk to the grocery store, just because you have bags and things to carry back.
Bobby,
So-
James has a question he'd like to ask.
Yeah,
Yeah, go
I
ahead.
just, about the other model characteristics, how does things like comfort get quantified in the modeling?
Yeah, so typically right now we use we don't like directly quantify something like comfort. We're gonna essentially do a study based off of the perceived comfort in an area, and then we're gonna take those perceptions and maybe put them on like a Likert scale and try to codify them or quantify them in that way. So we're never actually like measuring comfort, or for like safety, we might not necessarily be measuring like total crashes or thefts or something like that along their corridor. A lot of it's going to be perception based.
Yeah, so yeah, that's the part I'm trying to understand, is where does that perception base come from?
The perception base is largely going to go back to research that has been done that shows like driver comfort or like biker, like, so say we're looking at bicycle trips, for example, right?
Mhm.
Or bicycle modes, there's a certain level of perceived comfort, right, along a corridor, and that might be directly related to the volume on the corridor, right? So instead of saying, we have a variable that is comfort, or the quantified measure of comfort, we're going to have a variable that kind of represents what comfort might be. And so the research, right, when we're doing like biker comfort studies, right, might be the total volume on the roadway, right? So if you are, selecting to walk or not, or to bike, for example, and you know that your bike path is going to take you along like a corridor with a high vehicle volume on it, right? That might discourage you from biking because you're going to perceive that as not a very comfortable biking environment. So you're going to choose to drive instead of bike because you know that your perceived path is going to take you on high volume facilities. So we would, for example, we might use like some metric that correlates to the volume.
Well, I know AMATS does have mapping of level of stress for non-motorized facilities throughout Anchorage, Bowl, and beyond, I guess. So I would think that it might be useful if that was integrated into part of this, so that there was a linkage between the data that we're using in other plans to the modeling.
Yep, I agree, and I think the challenge, of course, is linking the estimation data set up with that. So designing your estimation data that you're going to be using to estimate mode choice in such a way that you're able to capture that. And that can be the challenge too in some of these mode choice models, is that in order to estimate the mode choice model, you need to make sure that when your estimation sample is capturing all these different variables. So this is important to know, like when you're going into designing your new household travel survey and onboard survey, right? On making sure that you're capturing data, right? And in the design phase with the understanding that, hey, we want to be able to capture more sophisticated measures of driver comfort or reliability in our mode choice models when we go to estimate the new travel demand model. So we need to make sure that when we're thinking about, when we're designing the household travel survey, that we are creating that planning feedback mechanism that we were talking about earlier, where you don't want to just design the travel demand model in a vacuum. You want to make sure, what are the planning policy questions that we're asking? And if we're talking about more sensitizing the model, right, to more walk and bike features, we need to make sure that we're designing the household travel survey in such a way that we're able to capture those things.
Mhm,
If we're not thinking
definitely.
about that out in advance of that, then when we get to the time where we need to estimate new mode choice models for the trail demand model, we didn't think about that in the design phase of the household travel survey, then there's not going to be a way for us to necessarily make the sensitivity of the model work because we never collected data. And then we're looking at situations is there research where we can transfer, or is there other work that has been done in other regions where we can transfer that information? And so that.
Oh, sorry, this is Joni really quick. I was just gonna chime in. Sorry, I don't have a way to raise my hand in here, but, so that, level of stress, metric that James was talking about, that was created for the non-motorized plan, and that was, I think a measure of, they looked at the posted speed, the presence of a side path or sidewalk, and the presence of bike lanes. I think there may have been another criteria in there, but if at this point in your guys's work on the model, would it be too late to incorporate, like, those seem like simple enough criteria that should be available in our GIS database to incorporate into the model? Is it too late to do something like that?
It is too late to do that. And the other issue is that we wouldn't have a way to estimate with that information. So we need to think about the design of the survey and how the mode choice models are technically estimated, right? And that has to be accounted for in that stage. So for example, the work that we did to sensitize the travel demand model in this phase of the update was to borrow parameters or transfer parameters from San Diego, where they did similar work in trying to capture land use and transportation interaction as it pertains to walkability and bikeability. But because we can't directly use the data that was conducted because this model was estimated primarily based off of the last mode choice or the last household travel survey and the onboard survey. And so we have limitations in terms of what parameters that we can bring in because those parameters weren't estimated based off that data. And so we can only go based off of, well, what have other regions done that will increase our sensitivity for the current effort? And then it's identifying, okay, when we do the next round of things, how do we build increased sensitivity to these things when models are estimated? But there's a technical step where we have to estimate these mode choice models, and the estimation of the mode choice model has to come from data that's collected in the household travel survey and the onboard survey. And if we're not including that information when we're having people fill out information in their travel behavior surveys, then we can't estimate the data, or we can't estimate the impact of these things at that point. That makes sense.
So, yeah, I have a question or follow-up question. So how would you, so in the future, if we want to do this in a future model, we wanted to incorporate that level of stress or comfort into the model. How would you collect those like 4 criteria that I mentioned, like posted speed
Yeah.
and presence of a bike lane and all that
In the surveys.
in a survey? Wouldn't that just be something that, I mean, because those aren't, you're not asking somebody like, what's the posted speed in your route? You're just,
So the way that I would approach it is that if you want to really get serious about modeling bike ped, then you need to have a standalone bike ped model to do that, because there are issues with the travel demand models because the unit of analysis in this travel demand model is a travel analysis zone. And the travel analysis zone is too aggregate to appropriately model like ped trips, because if you can imagine, you can look at some of the zone sizes that we have in Anchorage, and they're huge, and it's not going to capture all the bike. Like there's tons of, especially pedestrian traffic trips happening in the zones that we're not capturing. So what other regions have done is they have a separate bike ped model, and so the travel demand model runs and it figures out what is the total amount of walk bike trips. And there's some work that you have to do here too, because typically in a trail demand model, we're modeling utilitarian trips. And the utilitarian trips are, like work type trips and things like that. And there's a whole listing of like recreational trips. And typically the recreational trip pattern that a bike and pedestrian is going to take, for example, are like home trips, right? So you don't necessarily have a destination. Like you you have a certain amount of these trips that actually have a destination. You're going somewhere. And then you have other ones where, like, you know, for me, like I live like a half mile from a regional trail network here in Indianapolis. And I get on my bike, I leave my house, and I come back to my house. I don't stop anywhere. I go for a 15-mile bike ride, and then I come back. And so typically in trail man models, if you have a home origin, a home destination, the trip gets cut out. And so you have to create a model now that is sensitive to the utilitarian and non-utilitarian trips, because those are ultimately things that you want to measure, right? And then you need a separate bike and pedestrian model that has it like takes the travel demand model trips for bike and ped, the total global picture of what those trips are. And then if you want to further model them in more detail, then you need to get down to there's these zones called micro-analysis zones and pedestrian analysis zones. And those are where you need to start modeling at that level of resolution. And then what you would do is you would estimate a path choice model that's sensitive to these things like speed and comfort and the level of stress and stuff like that. And so you would look in, really what you're looking for is a feedback mechanism to say, hey, the level of stress, like what goes into level of stress, you know, you're not necessarily pulling in your level of stress index. I don't know if you guys put it on an index or you measure everything individually, but you have multiple things that go into that stress index, like the quality of the bike lane, is it grade separated path, what's the speed of the travel, what's the percentage of trucks, what's the total volume of vehicles and stuff like that. And you would put that into a new path choice model that would kind of figure out how to route these trips according to that types of stuff. And that's how it's been done nationally. If we look at state of the practice of bike and pedestrian modeling, it's pulling it into its own little separate bike pedestrian model and getting down into the details that you're talking about and estimating those things at those details. But you need to start at the household travel survey. So you need to say, okay, we want to do better bike ped modeling. In order to do better bike ped modeling, we need to be able to collect information on, say, someone did a bike trip, right? It's like, what is the path of that bike trip take? And, you know, the last household travel survey that AMATS did was a paper diary method, for example. And like the latest state of the practice for household household travel surveys now uses smartphone applications. And the smartphone applications, we actually get a route. And so we can actually get GPS traces of what path takes. So now you can start actually looking at like behavioral data. This person took an actual bike trip and this is the route that they took in the region. And so you have to set up your data collection processes and your planning processes. So you're identifying a need to do better modeling or better analytics on bike ped. You need to start with your household travel survey and sensitizing those things and making sure that the data that you're collecting at the household travel survey can eventually integrate into more sophisticated or more robust bike ped modeling tool.
So essentially we need a bike ped model.
And if you want to get into higher levels of detail, yes, yeah, than what the current model provides.
But before you get a bike ped model, you need the data first.
From the trend survey.
Yep.
Yep.
So I'm going to try to quickly get through this. Essentially, the mode choice model as an attractiveness of the mode is a function of its utility. And so the utility equation just describes the factors that influence mode choice for each particular mode. And there's one utility equation for each mode in the model. And the utility is a numerical value that can be computed for each mode, and it's equal to the sum of the parameters in the model plus a constant. And so you can think of this as like there's a parameter, and the parameter is going to be the size of the size of the impact, right, of the choice of you choosing auto. And so, and then you have a mode specific constant. The mode specific constant is essentially a value of everything that wasn't captured in these other parameters. So the utility is the weighted sum of the attributes. Parameters are estimated from survey data or borrowed or asserted from other regions. They convert the times and costs into utiles, which is just a standard measure of calculating utility. So it's not like it's a unit of measure essentially. And the sign of this is really important too. So if there's a negative value in here, then it's a disutility, has a negative impact on it. And this culminates into the mode choice shares, or the probability that you're going to choose a given mode. And we call this the logit model. And so we're going to skip through the assignment stuff, and we're just going to go to the AMATS model structure. So we have a spectrum of travel van models, right? From a 3-step model to a 4-step advanced trip-based, all the way to activity-based model on the right. And these are kind of like the different regions and where they fall, and you can kind of see where Anchorage falls. So Anchorage has a hybrid advanced 4-step model. And we'll kind of get into what makes it this hybrid trip tour-based model in a little bit. But it's one of the most advanced 4-step models or advanced trip-based models that you can develop in the country. So what is the format of the AMATS model? The model follows a general 4-step structure, but it has it's implemented in a much more complex fashion to capture regional travel behavior in more complex markets. And so we start with a network processing step. In this network processing step, we're calculating things like the capacities, the speeds along the roadway, the intersection capacity, and then we're going to go through and process our travel analysis zones. And we're going to start to create our trip duration models. And then we're going to get into calculation of various different, after auto assignment. So we're going to run through and preload the travel demand model with volumes. So auto assignments are performed really early on to where trip tables are assigned to the highway network. And it's to note that the AMATS models run several times or iterations. So the trip tables here are assigned to the auto network at the start of the model system, and that's in order to develop a travel level service matrices or schemes for subsequent model components. And what this does is it ensures that the demand output from the model is consistent with the demand used to estimate future travel times. And we're preloading this information so the model actually has some understanding of what travel conditions are at any given time in the model area. And this essentially allows us to create a set of level service matrices or schemes connecting to travel times and costs for each pair of zones in preceding steps. So the model actually has an idea. So when the model is determining various different factors, right, it's essentially has an idea of what travel characteristics are in the region already. So you can kind of think of this in a way that when you go out to leave and drive your car at the end of the day, you kind of have a general idea of what the traffic conditions are. So that's essentially what's happening in this process, or that's the underlying logic of the model process here. And then we actually iterate through this several different times. So the model actually runs through 3 iterations of this before generating its final assignment. We generate accessibility variables in the TAS processing step, and these variables are used to reflect the travel level of service from a given origin zone to all possible activities in the destination zones. Then we run trip generation. And then the next step, split these daily productions into the peak and the off-peak productions. Then we run the trip distribution model and the mode choice model separately for peak and off-peak trips. And the trip distribution models are a measure of accessibility from our mode choice model, or what we call the log sums. And the log sums represent accessibility of travel by all modes of transportation, where each mode is weighted by its probability or share of use. And then the mode choice model is going to split the trips by the purpose and into trips by purpose and mode. And then the AMATS model is going to run through its set of commercial vehicle models. There's a simplified airport or airport ground access model that represents auto travel to and from Ted Stevens. There's a separate simplified visitor model that represents auto travel to and from hotels made by overnight visitors on a given day, on an average given day in the Anchorage region. And then after mode choices run, trips are transformed from production and traction into what's called the origin destination format. so that they can be assigned to the networks. And after the model completes iterating through this 3 different times, we're going to get the final auto assignment is performed and transit chips are assigned, and the model reports can be ran. So the AMATS model has a total of 918 travel analysis zones. There are 4,500 network links and 336 controlled intersections. And within that network, we have different roadway geometry attributes, things like lane, speed, median type, functional classification. We also now include what's called the upstream functional intersection area. So that's essentially a measure of what the actual intersection area is of a given link. The network processing, the model calculates capacities at 2 points. There's a mid-block link capacity and intersection capacity. So the mid-block link capacity is a function of the lanes, the capacity per lane by facility type, auxiliary lanes, capacity adjustment factors, and then the intersection capacity is more impacted by intersection level things. So it's going to be like the capacity per lane by facility type, the green cycle ratios, number of turn lanes, lane capacity, and turn lane capacity, as well as an adjustment factor for capacity. And we have 2 sets of zonal accessibilities. The first set are the total number of intersections within a half mile of the model, households, employment, acres. So this is essentially how quickly or how much you can access within either a crowfly measure, or we have 2 different drive measures. We have a measure of employment within a 30-minute drive and a measure of employment within 30 minutes of transit travel time. And then we have a second set of accessibility measures, which are factored into the destination choice model for drive alone, for walk, for to employment, and then for retail employment, we have drive alone, and for total employment, we have walk transit trips. And the AMATS model has a fairly sophisticated household submodel. The household submodel essentially generates household size and household income based off a set of curves using the average household size and what's called the income index for the travel analysis zone. So the income index is the ratio of the average zonal income to the average regional income. And from there, we can plot what the household income and household size characteristics are going to be for any given zone. So instead of having to process all this stuff manually, the model automatically has these household submodels and estimates through regression models and logit models what the prediction of the household characteristics are going to be. And those are matched to census values at the regional level. So we have 7 trip purposes in the AMATS model. We have home-based work. We have home-based school, which is any trip between home and pre-K and grade 12. We have home-based college, which is any trip between home and college, university, and trade school. We have home-based shopping, home-based other, which is anything, any trip between home and another destination that's not listed here. And we have 2 non-home-based trips. So we have non-home-based work and non-home-based other, and those are trips between work and any other place besides work or home. The trip distribution step is performed using a destination choice model. The simplified models that we talked about earlier were gravity models. And so a gravity model is a very simple destination choice model where the only values that are considered in the destination choice model are impedance or travel time values. But in the AMATS model, it's more nuanced. And so these are implemented for all home-based purposes. And then it's not sensitive to not only distance or travel time, but also things like enrollment, retail, accommodation, food service, entertainment, healthcare, social care, professional services, and government employment. So we consider other factors in the determination of where you're going to travel. So it's not just destination-based metrics. And then we have different location-specific constants to represent Anchorage Bowl, Matsu Borough, and Eagle River. And that's just to capture some of the nuances in the total AMATS model area, because we also modeled the area of Matsu and Palmer. And so there's more interaction, for example, in Matsu and Palmer with Eagle River than with Anchorage Bowl itself. And likewise, Anchorage Bowl has more interaction with Eagle River. So the location-specific constants help us dial in that type of district-to-district flow. in the model itself. The mode choice model that we use is a nested mode choice model. And essentially the nested formula reflects unequal competition amongst modes. So this is similar, or that is a similar alternatives are grouped together to reflect higher cross elasticities between them. And the nested logit model utilizes an extension of the multinomial logit model that we described previously to accomplish it. And in this structure, similar set of alternatives are together under the assumption that the error terms for those alternatives are more similar than non-nested alternatives. So what this is saying is that basically the elasticities or the differences within these are smaller for everything that's related to auto and everything related to non-motorized transit and school bus. So you can see that in transit, right, for example, we have different types of how you access transit, right? So we have walk access to transit, we have park and ride access to transit, we have kiss and ride access to transit. And so we group the elasticities are a lot smaller here than they are between the other modes. And then likewise for non-motorized, we have walk and bike. And so the way that the assumption that it works in the travel demand model is that the walk and bike modes are more similar to each other than the auto modes. So the enhancements that we made to the mode choice model were primarily around sensitizing the travel demand model to land use transportation interaction. And the parameters were scaled to match in-vehicle time. And the model makes use of 3 additional variables. We have intersection density, dwelling unit density, and employment density, and then we interact those variables on each other to come up with different sensitivities to land use characteristics. So these essentially will relate to how the travel demand model or how the mode choice model looks at things like impacts to like smart growth. So essentially, where you have compact urban development, you're going to see a further increase in walking trips and walk transit trips than you would without these parameters. So essentially, this is capturing more smart growth principles in the mode choice model itself. And then the non-home based model are trips where neither end of the trip is the home of the traveler. For AMATS, we implemented a novel approach to non-home based trip generation and distribution, or non-home based trip generation, distribution mode trace that takes into account actual home-based trip attraction locations and modes, and the generation of the non-home based trip ends. So essentially what we're doing is we are calculating all the home-based trips first. And then after we calculate all the home-based trips first and go through trip generation, distribution, and mode choice, we then are saying that the location of the non-home-based trips is a function of where the trip ends for the home-based trips are. So if you can imagine that a home-based trip has to begin or end at home, and a non-home-based trip can either begin or end at home. And so what this is doing is it's linking the non-home-based trips to the trip ends of the home-based trips, how they would actually be consistent in their tour. And this is what makes the AMATS model a hybrid trip tour based model. And that's because we're calculating trips independently of each other, but then we're linking or making them consistent with the tour patterns by ensuring that where a home-based trip end is, that is the only location where non-home-based trips can occur. In simpler models, you would essentially just calculate a non-home-based trip rate. And so if you were to actually compute where your non-home-based trips are and then compare it to where your home-based trip ends are, they wouldn't be connected together. And so this essentially links those together in that fashion, which is a novel approach to doing that, which has only been done, I think, now for probably about 7 years in travel demand modeling. And then for commercial vehicles, we have long haul trucks that are based off truck attribute GPS data and are expanded to count data. And then those are assigned at the externals of the model and routed into the model area. And then we have short haul trucks based off the FHWA criteria that generates commercial passenger vehicles, freight goods vehicles, and service vehicles. And then those are summed into truck classifications for single unit, multi-unit trucks. And this is just showing that in highway assignment, so in the AMATS travel demand model, we don't assign walk bike trips to a network. We only assign commercial vehicle trips, we only assign driving trips, and we only assign transit trips onto the network, onto a routable network. And this goes over, basically we have all the different drive alone categories. We have shared ride plus 3 and light trucks, and then we break these out by their value of time category, which is their market segmentation by income grouping. There are 3 periods in the travel demand model. We have the AM period, which is 7 to 9 a.m. We have the PM period, which is 3 p.m. to 6 p.m. And we have the off-peak period, which is 6 p.m. to 7 p.m. and 9 a.m. to 3 p.m. So the next step is, how are we using the travel demand model? So some of the ways that we're using travel demand model are exactly how you've seen us deliver data to date for the MTP. We're doing vehicle miles traveled analysis, looking at different scenarios, comparing those scenarios, and looking at how much trip making activity is there. We've got various different vehicle hours delayed, which is just a measure of congestion. So what scenarios are developing more or less congestion between each other. We're looking at mode share analysis, which is looking at the different types of scenarios that we have here and how are these generating differences in mode share. And it's probably important to note here too that with the sensitivity to denser land uses, we're seeing increases of walk and bike trips in this mode. So where you have dense land uses, right, you're going to have more walk and bike trips that are associated with those, as well as more transit trips too. So that's consistent with the enhancements that we made to the model to sensitize the travel demand model to land use impacts. But it's important to note, even with elasticity, like the elasticities with walking and biking, that the elasticities between mode shares, especially walk and bike, is really, really minor in a region. So we're talking about 1 to 2% shifts in elasticities for mode share for walking and bike for making improvements. So the relative elasticity is relatively small for walk bike, and that's consistent with what we see across the country. That's why it's important when we're doing various different planning activities that if we're advocating for increase or improvements to walking and biking, that we're also combining this with things like safety analysis and stuff like that, because the biggest impacts or the biggest planning impact on walking and biking is going to be on the safety side. Then we're looking at transit analysis and boardings, and this is an example of system level boardings from each of the scenarios that we're conducting. One thing to note too in this trail demand model is that between the last update and this update, the people mover system, the routes changed. So the last iteration of the trail demand model, we actually did route level calibration results, but because the onboard survey that was used to estimate the model is different from the routes that are in the trail demand model, now we only calibrated to system level boardings. So with a new onboard survey, that would allow us to do more calibration results at the route level. And then that would allow us to further break out impacts by route level instead of just system level boardings. So this is an example of just transit and general vehicle analysis and travel time. And its caution is we always want to make sure that we reality check these. So the model uses an aggregate static assignment method over multi-hour time periods. And what a real world travel or experience at a specific point in time, even in a well-calibrated model, might be like much different than the model forecast. And so best to use fairly long routes to even out link level variation. So we're looking at corridor level groupings instead of intersection level groupings. And Bart, I see you had your hand up.
Yeah, thank you. Going back on what you said about the onboard survey and changing routes.
Yeah.
So does that mean anytime we change routes in order for the model to be calibrated, we have to do a new onboard survey?
No,
like if we do any kind of route alignments?
It depends on what type of where the target is at the calibration. So if you're doing If you're wanting to have a model that is calibrated at route level calibration, right, then you have to have an OD survey that matches with the routes that were estimated at a time. Otherwise, if you change the routes, right, so say you had 5 routes, right, and you expanded that to 25 routes, the survey would only be sensitive to 5 of those routes, and those routes might not be valid anymore. Like those routes might just purely not exist. So if we want to do route level calibration results in the model, we need to have an OD survey that matches the routes. If that in this case, right, where we didn't have an OD survey that matched the routes, we couldn't calibrate the routes anymore because we would calibrate to the OD survey results, right, or the expanded OD transit onboard survey. So all we could do is take the boardings that we had, the system level boardings, and calibrate to that.
So
But yeah.
can you describe the difference or the pros and cons of a route level calibration versus just the on-off boarding calibration?
Yeah, if you did a route level calibration, then you can actually get into more like transit planning work on a route level. And so there's additional work that you need to do in order to get to like more like route level type of transit planning. And then you generally need to have more onboard survey data collected, and then the model can be calibrated to those onboard survey conditions. And then you can start looking at things like adjusting or playing with different parameters that might affect transit usage and doing more robust transit planning activities using the model.
Thank you.
Yep. But again, it all winds back up to the data that you're collecting in the beginning. And then what you're modeling. So you want to have an idea of, okay, this is the kind of planning work that we are trying to do or wanting to do, and what data do we need to be designing way up front in the beginning of the process that feeds in the model system. So if you're looking at, I want to be able to start doing this type of analysis using the travel demand model, now is the time to start asking those questions of like, okay, we're not able to do, reach this level of planning analysis. What do we need to be doing at the data collection process to make sure that we're able to get to that point when we get back to the cycle of updating the model? So it's really important that we have these planning feedback mechanisms in the processes to understand what data do we need to collect, and what is the model system? How does the model system need to be designed so that we're capturing those policy and planning questions that you want to ask? So a quick note here is just that you want to note that the demand model may not show a lot of the variation in these unless the different scenarios have different congestion effects or notably different routing or other configurations. So the big thing here is that you don't necessarily want to look at an intersection level, you want to look at a corridor or at the route level. So we can do things like speed analysis. We can kind of look at the corridor. So this is an example of an output from the AMATS travel demand model, and this just looks at the speeds. And this one's just a little bit more robust. So it's not the aggregate speed. This is the difference from the congested versus the free flow condition. And then we can do things like capacity level of service analysis. This is, probably historically what the model has been used for is more of this capacity level of service analysis, but in planning, we're getting further and further away from just doing a level of service analysis. We can do planning level roadway operational analyses. And roadway efficiency improvements are often becoming more prevalent investments in many urban areas. So we're looking at ITS investments, intersection signal coordination investments, intersection geometry optimization. And the AMATS model is sensitive to turn lane configuration and signal timing and can examine things like the packages of operational investments over broad areas, such as the MTP update, or even corridor scale investments across multiple intersections. But the big thing here to note is that the travel demand model should not be used to test single intersections, single operational impacts of the intersections. The appropriate analysis to use for signalization or for automobile or intersection level analysis or intersection type analysis is to be looking at all the intersections within a corridor. And this has to come down to the type of assignment that we're doing in a travel demand model, which is a static assignment. It's not robust enough to do operational level analysis or operational level characteristics of the intersection itself. So we can also look at things like the transportation outcomes of land use scenarios. The density and spatial configuration of future growth in a region can have a significant impacts on transportation system performance. The policies that can concentrate growth more densely, citing major new employment centers or facilities, different overall growth scenarios, changes to expected growth in major special generators, and the effects of higher density land uses on active transportation mode choice, such as 4D analysis. And we get to that here where we can look at things like transit and active transportation usage as a result of land use and facility investments. And we can look at things like the built environment distribution of residences and opportunities that affect travel choices. And the model or the land uses that change the location amount of land uses that change the location amount of destinations. These are land uses and or transport investments that change the network design, such as the intersection density of the active transportation enabled network, and change it to both residential and destination employment and density. So the model is not directly sensitive to supply of bike and pedestrian facilities, and this is an important note here. So like I said before, we don't assign walk and bike trips, and that's because the level the transportation network supply, the routes that people would choose for bikes and pedestrians are contained in those travel analysis zones. And you can kind of see in the picture above is, if this is a travel analysis zone, this whole square, for example, right, we would have our major roads on the edges here that you can see. And then you can look in here and you can see what the path choices are, right, for bike and pedestrians. And those path choices, right, are within the zone. And we wouldn't necessarily capture those in the travel demand model, or we have a situation where we have a really more of a suburban development pattern. So we don't have like a direct route. We have some circumnavigating route where this impact of pedestrian and bicycle behavior wouldn't be captured. So it's important that in order to really effectively model bike and pedestrian trips, you need to have a network supply or network that is actually representative of the network that pedestrians and bicycles are using. And the transportation network that is in the travel demand model as it currently is really only able to capture our people's choices on the main automobile or the main volume carrying facilities in the region. So in order to make enhancements to the travel demand model on the network supply side for bike and pedestrian activity, we'd have to have a separate bike ped network where those trips can be routed on top of them. And the model isn't capable of doing that, or if we did it, it would be fairly inaccurate. And some other things that you can use the travel demand model for that have been used in other regions, you can do evacuation model with the travel demand model. It's important to note that you need to combine an evacuation modeling with another meso or microscopic simulation. This is to capture congested conditions under an evacuation event. What this basically means is that the current travel jam model uses volume delay curves that are based off the highway capacity manual. And they have limitations once they run into extreme congested conditions. So when you get to oversaturation or super saturated events, the current travel demand models, assignment algorithms aren't able to actually reproduce what the true level of delay would be. And in general, travel demand model, without combining it with a meso or microscopic simulation, you would only be able to get something like to within your travel time results for an evacuation event, a no notice evacuation event, could be 50 to 100% off on the total travel times without taking that into context on the assignment side. So we can also do pricing and tolling studies with this, and there are path-based and choice-based toll demand approaches. We can look at things like toll road diversion impacts. We can look at various pricing strategies around fuel taxes, BMT charges, parking charges, point tolls, facility tolls, demand response variables. We can look at transit fare changes as a impact pricing and tolling studies. We can look at congestion-related performance impacts on these as well too. So there's lots of different pricing and tolling studies that you can do actually where the travel demand model is integrated into that analysis. You can also use the transportation model to develop transportation impact fees. I don't know if impact fees are utilized in Alaska or not, other areas of the country. What was that, John?
I said no.
No.
Far as I
Sometimes,
know.
yeah, sometimes there's strong political opinions on whether impact fees should be assessed or not. But in other areas of the country, they've used the models to help support and identify impact fees analysis, and you can essentially create reasonable uniform benefits from the travel demand model. And then you can actually come up with impact fee rates that can be assessed onto the developers. So if you have if you wanted to estimate what the impact of a 1,000-person new subdivision would be, we could actually create an impact of what the new daily trip ends are for that new development, and then come up with the cost as it relates to serving the traffic under the previous existing conditions, and what they would be after the development. And from there, you can essentially get a cost to serve existing traffic and the cost of the impact fee. And then from here, you can see where you can just essentially calculate an impact fee per new daily trip ender user. So that could be assessed onto each of the houses in a subdivision to determine the impact on the transportation system or what the impact is to it. And then we have things like benefit cost analysis and then equity and performance measures, where we take the travel demand model, we plug that into a set of performance measures, and then we can actually calculate the benefit and cost calculation from the travel demand model. And from there, we can look at things like the benefit, travel time and cost, the user benefit, travel time reliability. We can look at physical activity benefits. We can look at vehicle ownership costs and their benefits. We can look at things like travel options, like the destination, the mode accessibilities. We can look at highway safety and integrate that into travel demand model outputs, where we're calculating what the benefits of a project might be on fatal injury, property damage only collisions. We can estimate the impacts on emissions. So a project might, reduce or add to tons of CO2 or PM2.5. Nitrous oxide and VOCs. We can calculate things like the impact of surface water runoff on projects, looking at VMT-based costs of impacts. We can look at the impact of noise in the area too, based off of VMT-based costs of impacts. We can look at things like vehicle operating costs, like the gallons of fuel consumed, or VMT-based non-fuel costs. So I think that the benefit cost analysis and equity and performance measure stuff is an important and increasingly important aspect of travel demand modeling, where we can take the travel demand model, combine it with some other analysis, and actually produce more robust measures of what the impacts and the benefits and who's benefiting from these projects are.
Yeah, Bobby, I might just add that we're taking a look at that component, right? Because we can't do that currently, but we're taking a look at how we might be able to capture that information, that data, and then apply it to projects.
That's correct. Yep. So we're looking at kind of how that can happen, and this produces a more robust set of different measures. And it's not just the travel demand model. We're bringing in multiple different analytics and using outputs from the travel demand model to help inform those. And the travel demand model is a huge component of coming up with these, because it has origin destination impacts, we have zone-based impacts, and we have link level impacts. And so this ends up being a really cool way to help align the travel demand model to the performance measures or the adopted performance measures that the MPO might have, and get to more impacts that are beyond just the standard VMT, vehicle hours traveled type of analysis, or vehicle hours delay. But we're about 25 minutes over. I apologize, but that's the end. So I want to kind of open it up here to questions. We've gone through a lot of content on the travel demand model and potential use cases. So wanted to give everyone a chance to talk through things that they might have thoughts on.
Well, just speaking for myself, lots, well, new information there for me, that was very helpful and, insightful. So I appreciate, the primer and, hopefully everyone else got some things out of this and get a sense of, how sophisticated this model is in some of the things it's trying to capture, and then also some of the limitations that it can't, like with some of the questions that Joni was asking, that you gotta have the right tool for the job, and this channel demand model isn't necessarily, the silver bullet that will answer all of our questions for all modes, all choices, that kind of thing. But it is a very powerful tool. Questions?
Yeah, I guess on that note, and I assume that's sort of the answer to this question, is that it's not the be all end all tool for everything, but is there any like input for winter? Or is it, is that just sort of like not included or averaged out or something? Cause you also, because the flip side of that you mentioned was, visitor travel or something like that, and we have such a high influx of, tourism in the summer, but then that really drops off in the winter. So I guess that's sort of the opposite effect potentially, or opposite dynamic maybe in some respects as like our winter travel.
Yeah, so in general, the travel demand models capture a typical anchorage day. And the month that we say is like the typical anchorage month is sometime in the fall. So the model in general represents an average, right, of traveling, and that is typically falls in the fall. So in your winter months, it's less than that. In your summer months, it's more than that. And there are examples of different regions where they're really interested in knowing, they might want to know what the winter impacts, but essentially it's an annualized impact, what the annual average impact is. I think where we get into cases where models start to break out of that are places that are huge tourism industry places. There's usually a really big demand to know what the summertime travel is like, because that's, what they want to plan for. And so in those cases, sometimes there are a lot of cases, there's more robust visitor or tourism models that adjust the model and are essentially reflective of more summertime conditions, or the conditions really where they have peak tourism happening, so they can look at what those impacts are and what the differences are between like the tourism months versus the annual average months. So if you're wanting to look at things like the impact of tourism and how travel behavior and origins and destinations and mode choice and choices change during those big tourism impacts, you'd want to make sure that you design a model system around the ability to answer those questions. And right now, the visitor model and the AMATS model is fairly simplistic, and it's more representative of that like fall condition. So like what are the visitors like on average for the entire year? What does that look like? As opposed to during like the peak tourism season in the summer.
Sure. Okay.
Looks like Bart has his hand up. Go ahead, Bart.
Yeah, thanks. And thanks, Bobby. This was really helpful, and I did miss some of it, but I'm going to watch the recording, and so I apologize if you've already covered this. But knowing what you know of the AMATS model and some of the ways that we want to use it, maybe for more non-motorized or other things, what are some of the next steps that AMATS should be thinking of? Is it data? Is it just kind of like defining what we actually want?
So I think what I would here's how I would start is I would start at the planning and policy level. Like, what are the planning and policy questions that you're asking that you're not getting an answer for? And I would be brainstorming on those things. These are the kind of planning and policy questions that we want to ask. Or these are the planning and policy issues that we have that we're either identifying through planning processes, through publicly identified need, or are being identified through stakeholder groups or through elected representatives. And I would be coming up with an idea of, okay, these are the planning and policy issues that we have in our region. And then that is going to pose a set of planning and policy questions that you're going to have to ask of, okay, well, how do we look at solving these issues? And what are some of the metrics that we need to be able to generate to help us make informed decisions around these issues? And from there, you're creating like the planning feedback into this. And then it's, okay, how are we using the travel demand model now? And what are the things that I wish that I was getting out of the travel demand model that I'm not getting out of the travel demand model today? And then once you've kind of sat down and formulated those things, then you need to start at the, okay, this is what we need to do to integrate these into the travel demand model. And there's data needs around these. And what are those data needs? And so how do we need to design the household travel survey, their onboard survey, or, it could be, if you wanted to look at, more visitor travel, would be, okay, we need to do a visitor survey. How do we need to design the data inputs so that we're able to measure these things? And then how are we backing up those decisions? How are we calibrating those decisions, right? So what's the data that we're collecting now that we can use to help calibrate those? And then and so kind of getting all your data needs in order too. So you have the data that you need to be able to estimate these things. You have the data that you're going to need to calibrate these things. And then do you have both of those? And then from there, you can start with, okay, now we can actually build, these are what we can build the travel demand model. And some of those answers, right, might be, the travel demand model isn't appropriate, to answer that question.
Right.
And that's like one of the things you want to come or, to figure out too, is the travel demand model the appropriate tool for this? And if we go back to like bike ped stuff, for example, you can go through the process of calculating, or generating all these, getting all your input data and your estimation data in order, right? But if you're not collecting, if you don't have a bike ped counting program, if you're not collecting bicycle and pedestrian data out on the network, on the bike ped network, then you have no way to calibrate that model to real world conditions. And so you also have to look at your data collection efforts, and are we collecting enough data to do the type of analysis that we're doing as well? And so, Bart, I don't know if you guys have like linked fare card systems at People Mover. And so so if you wanted to better capture like linked trips, right, you need to go to a system where you have like a linked transit card, right?
Right.
And you can actually track, you can trace someone through the system. Yeah.
No, cool. It's so much.
It is truly drinking out of a fire hose, and even in 2.5 hours of talking with it, it's still like, gets to surface level in it. And so my hope here is that I've been able to provide some added insight and hopefully be able to start some conversations within the region amongst the planners on what are the things you guys are wanting to accomplish, and getting the kind of those gears in motion for where you want to be in 5 years on your planning capability.
Yeah, I think just a closing thought that on that very same point, that those conversations are starting now with Fairbanks MPO and this new Matsu Borough MPO, and finding out where there may be some connections between the three that we can collaborate on potentially, and or not. So yeah, I think it's a lot of great information that will generate some more thinking and questions.
Yep. And I'm happy as you kind of walk away from this and you start thinking, and feel free to reach out at any time. I'm happy to pick up the phone. I love talking about this stuff. It's important, and happy to either give you my opinion on kind of things that we've done, or if I can't give you an opinion or you want another opinion, I'm happy to connect you with other colleagues here at RSG who can certainly answer some of these questions in more detail than I can. So always happy to make those connections and have those conversations.
Great. Well, thank you, Bobby. Great job. Really appreciate you taking the time to help us understand this more, and we'll be talking with you again soon.
Yeah. James, did you want to talk? James, did you want to talk more about the mode choice, destination choice stuff?
I got a message from Aaron said he wanted to be in on that, so maybe you and I can reconnect at another time
Sure, absolutely.
and have that
Yep.
conversation.
Yep, and I can pull in some other people too. So if we want to kind of have that conversation of, when do you, do you do a pre-destination choice model, a mode choice model, or a post-destination mode choice model? We can certainly give you an understanding of kind of when it might be the best practice to do that. So.
Yeah, cool. And if you've got any written resources on that just, for something I could flip through, you can send that my way.
Sure.
That'd be fun. And but yeah, I'll reach out to you and maybe set something up a little down the road.
Sounds good.
All right. Thanks a lot, Robert. Really appreciate it.
Thanks, Bobby. Appreciate
Thanks,
it.
everyone.
Thank you.
Bye now.
Thanks.